Rational functions. So previously we talked about the difference between an expression and an equation. So just to recap, an expression is just a mathematical statement that might have numbers and variables, but it's not equal to anything. A rational equation sets two expressions equal to each other. So the left-hand side must be equal to the right-hand side, and there's probably a value of x that makes that equation true, but it's not guaranteed. But probably there's a value of x that makes each side of the equation equal to each other. A rational function is a relationship between what we call the function f and x. So here's an example of a rational function. F of x equals 5 over x plus 2. So the value of the function f depends on what x is equal to. So you can find the value of the function when x is equal to 0 by replacing x with 0. And you get 5 over 0 plus 2, or 5 over 2. So the value of the function at x equals 0 is 5 over 2. What we often do is we replace f of x with y. So you're used to seeing lots of equations that are like y equals 3x plus 6 or something. So this is another way to write a rational function. But what's really important is that a function is a relationship between two variables, like f and x or y and x. So the value of the function depends on what the value of x is. Functions have domains. So when we consider the function f of x equals 2x minus 6 over x squared minus 8x plus 15, this function has a domain. That is, as a recap, all the possible x values. All the possible x values that you can stick into this function. Now for a rational function, what would stop us from putting in any given x value? And it comes down to the non-permissible values. Basically anything except the non-permissible values. So we're going to find the non-permissible values of f of x, which means setting the denominator equal to 0, or we'll say in this case, it's not allowed to be equal to 0. So we can factor this equation. Two numbers that multiply to positive 15 add to negative 8. That'd be x minus 3 and x minus 5. Cannot be equal to 0, which means that either x cannot be equal to 3 or x cannot be equal to 5. So those are the non-permissible values. So the domain is all values of x, and we've used this terminology previously, but that little e there sort of looks like a funny looking e. That means x is in the set of the real numbers, or x is all the real numbers, except we have to note that it can't be 3 or 5. So this statement here is how we would write the domain of the function f of x. X can be all real numbers, except it can't be 3 or 5. So that's describing the domain. Another type of question we might be asked is to evaluate the function at a certain x value. So what is the value of the function when x is equal to negative 2? So you can see that the spot of x has been replaced, there's x, it's been replaced with negative 2, which means x is equal to negative 2. So f of negative 2 means that we're replacing wherever x was with negative 2 in the function. And once we replace it, we can go ahead and evaluate this function to determine what its value is. So on the top we have -4 minus 6. On the bottom we have +4 plus 16 plus 15. So that would be -10 over 20 plus 15 is 35. And I can simplify that. Each side can be divided by 5. So f of -2, the value of the function when x equals -2 is -2 over 7. 10 divided by 5 is 2. 35 divided by 5 is 7. So we evaluated the function f for a given x value. Something else that we can do with a given rational function is that we could be told that the value of the function is equal to 1 at some point. So that means that f of x, if f of x is equal to our equation 2x minus 6 over x squared minus 8x plus 15, we're being told that the value of the function is equal to 1, but we don't know what the x value is. So in a question like this, what we can do is we can find what x value gives us the function value of 1. So we just have to go ahead and solve this equation. And at first it looks tricky, but we're just going to multiply each side by what's in the denominator. You do this before or after factoring to get rid of the denominator. So that leaves us with x squared minus 8x plus 15 is equal to 2x minus 6. And now I solve. So subtract 2x, add 6. So that would be minus 2x plus 6, x squared minus 10x plus 21. And sure enough, that can be factored with x minus 3 and x minus 7. So that's a simple trinomial. Minus 3, minus 7, they add to -10, multiply to positive 21. So that means that the x values of 3 and 7 both solve our equation f of x. But what we should do is check if there were any non-permissible values, and those would come from the denominator of the equation. So what were the non-permissible values? And we saw those earlier from factoring this expression. The non-permissible values were x cannot be equal to 3 or 5. And so sure enough, one of our solutions is actually invalid. We have to reject it because it was one of the non-permissible values. So always checking those non-permissible values. So I want to graph this function just to see what it looks like, and so we can make sense of what we got for our answers. So I'm going to use this program Desmos, this website called Desmos, which is a free graphing calculator website. It's a really, really great website for any graphing that you need to do, and it's really intuitive. So I need to type in a fraction, so I'm going to write y equals to make a graph of this function. And then I just press the backslash, or I should say / symbol, to create a fraction. And now I can fill in the top, which is 2x minus 6, and the bottom, which is x squared. And so to do a squared, I press Shift 6, which is that little hat symbol, and add my exponent, minus 8x plus 15. So now I have a graph of the function that we've been exploring here in this example. And Desmos is really nice. You can click anywhere on the graph and look at what the different values are. So you can see right away why x equals 5 is a problem for this graph. So we saw that the denominator factored into x minus 3. So let me actually replace it with x minus 3 and x minus 5. And so that meant that there were disallowed values at x equals 3 and x equals 5. And so you can see what happens at x equals 5. When x equals 5, as x gets closer and closer and closer to 5, this function kind of flips out. And in this case, it shoots off. Depending on what side of 5 you're at, it shoots off. So here we are, 4.94. It's heading down and down and down towards negative infinity. And on the other side of 5, as you get closer and closer to 5, it shoots up towards positive infinity as you get closer and closer to 5. So that's where you can see the behavior around x equals 5. And so that's what happens when you have or one thing that can happen when you have a divide by 0 error. The other value we have is x equals negative 3. So what's going on at x equals negative 3? Or positive 3, I should say. So if we go to x equals 3, what we actually see is that we're told there's basically this point on the graph where the function is undefined when x equals 3. You see that word undefined. And if we stick values in for x equals 3, what we'd find in our function is that 2 times 3 minus 6 is 6 minus 6 is 0 on the top of the fraction. And on the bottom, we would have 3 minus 3 is 0 times something is 0. So what happens at x equals 3 is that our function turns into 0 over 0, which is not allowed. Even if you have 0 on the top, you're never allowed to divide by 0. So right here at this one particular point, x equals 3, we basically get what we call a hole in the graph, where we just have this one value that's not allowed to be, what we call undefined.